so inverses are something you learn about really early. They may not be called inverses. But a really good example of very simple inverses are these two functions that I have given you right here. F of x equals x plus 6 and g of x equals x minus 6. You learn this whenever you're learning math at very young ages, because the first thing that they teach you whenever you're very small is they teach you how to add. And then what do they teach you after that? Subtraction. Right? They do teach you multiplication after that, but not directly. They teach you subtraction after you learn how to add, right? Because those undo each other. The opposite of adding 6 is subtracting 6, right? They are inverses of each other. They may not even use that word whenever they introduce it, but addition and subtraction are inverses. And then you move on, and then they teach you multiplication, right? 3rd grade multiplication. Henry's got to do it this year. So 3rd grade multiplication. After multiplication, what do they teach you? Division. And those are inverses of each other, right? Multiplying by 2 is the inverse of dividing by 2, right? They undo each other. On Desmos, graph these two functions for me, this f of x and g of x. Graph those two. Graph these two functions. F of x equals x plus 6. G of x equals x minus 6. Type those in for me. All right. Let's see. I'm going to type it in real quick too. Okay. So, tell me some things that you notice about these graphs. Okay. They are parallel. Oops, I did not mean to go. There we go. They're parallel. Okay. For that, that's the main feature that sticks out here, right? I'm going to have us graph another one. Let me add this to notes, that'll be better. Let's graph f of x equals 3 times x. What would the inverse of that be? Not negative 3. Divided by 3, right? So x divided by 3. Those would be inverses, right? Multiplying by 3 and dividing by 3. So you can leave these two up if you want, or I'm going to do another Desmos tab actually. All right. Now are those parallel? They are not. These are parallel. These are not parallel. Okay? So, that is not going to be like, being parallel or not parallel is not going to have anything to do with whether or not they're inverses, right? So it's a key feature, but it doesn't have anything to do with if these are inverses. I'm going to do something here on Desmos, if you, and this is a good thing for you guys to know how to do, so follow along, make sure you can do it. Up here, if you hit the gear right here, it is going to have a button right here where you can create a table for that function. So let's create a table for both of those right there. It's not immediately helpful to see this table right here, but I'm going to that second table and add some more numbers. 3, 4, 5, 5, 6. If I look at this table particularly at the whole numbers there, do you notice any similarities between my equation here, or my numbers here, and my numbers here? In fact, I'm going to take out these they're giving me decimals because they're kind of clouding my judgment here. Let's just look at those. So think about what we see here and what we see here. Anything you notice? They're flipped, right? We'll see if that happens on the other one. So like 0, 0, it can flip and you don't really even realize it's flipped because it's the same number. But here I had 1, 3 on this graph, but I had 3, 1 on this graph. Right here I had 2, 6. Here I've got 6, 2. Okay, let's see if it does it on the other graph. Let's see if it does it on these. So, okay, so when I've got 0, 6, 1, 7, 2, 8. Now I don't really see any that are necessarily flipped, but if I flip 1, 7, what would I have? 7, 1, right? I just don't have enough numbers typed in. Let's try 3, 4, 5, 6, 7, 8, 9, 10. So like here I got the 0.17. I got the 0.71 right here. I got the 0.28. There's 8.2, right? Does it look like that same thing is happening here? Okay, so this is what is going to happen with an inverse. Those x and y coordinates are going to switch whenever you have an inverse. It should sort of make sense because if I have 2 and I add 6 to it, I get 8. Well, if I have 8 and I subtract 2 from it, I get 2, right? They undo each other there. So, on your graph right here, I want everybody to go down to that third line and type in this equation, y equals x. And if you have done the same over here for the 3's, type in y equals x. Make that one green also. Okay. What are you noticing here? That green line here, what's happening with it? Straight through the middle of those, right? What about over here? Straight through the middle, okay? So what's happening there is it is a line of symmetry for our graph. So the graph of a function can be reflected over the line y equals x to produce a graph of that function's inverse. Okay, this is always true. So this is a place Desmos is going to come in handy whenever we're asked for inverses. We're going to learn how to do them algebraically by hand, but Desmos is a good tool to go to check. Because if you graph a function and its inverse, you should always see y equals x go right through the middle of it. If it doesn't, like for example, if I change this to x divided by 5, that's not, let me do x divided by 3. If I put a plus 2 over here, you can see that green line's not going through the middle of it anymore, right? Those aren't inverses of each other. So, let's look at a few graphs, because even though Canon wishes that they would go away, they are not going to go away. Actually, first, before we do graphs, let's do this. So an inverse function will undo what was done by an original function. Do you not have that? Did I skip way ahead? What happened? Wonder why that didn't print. All right, is your next one this graph right here? Okay, I don't know why it's not there. We'll write it down real quick. It's okay if you don't have it. I'm going to fill it in up here. If you want to go back and scribble this in somewhere, that will be fine. Sorry about that not showing up. I don't know what I did wrong there that didn't show up. The notation f with a -1 exponent of x is used to denote the inverse of a function f. You might also see g inverse of x. Yeah, that might use a different letter than f. But if you see this little -1 exponent right here, that is indicating an inverse. So, example 1 and example 2 are inverses we should be able to come up with without actually having to learn how to find the inverse. What is the inverse of x minus 5? X plus 5. The inverse of subtracting 5 is adding 5. So if we were writing the inverse here with inverse notation, we would do f inverse of x equals x plus 5. A side note, Desmos is not like inverse notation, and if you try to type it into Desmos, it's not going to work. You just got to call it g of x or something. For example 2, what would that inverse be if I've got multiplying by -7? It's almost. Like if I take a number, if I do -7 times 6, that would give me -42, right? So if I want to get back to 6, what do I have to divide by? -7. So it's, whenever you're multiplying or dividing, you don't change the sign. So this would be x divided by -7 for that. So that's just like a little introduction to the notation there. Nope, don't back up. We're going to do this last one. Okay? If I am going to graph the inverse of this, I've got these points, 1, 3, 6, 3, 6, 0, 1, 0. You can think about flipping it, but to me it's very hard to picture that, right? Because it's going to go, like this line right here is going to go through the graph. It's really hard for me to picture flipping that. What did we say happened with our points? They switched, right? So 1, 3 would become 3, 1. So I could graph this point here, 3, 1. That's this point here. The next point is 6, 3. That's the blue point right there. 6, 3. That's going to be 3, 6. So 3, 6 would be right here. The next point is 6, 0. That is the green point. 6, 0 becomes 0, 6. 0, 6 is right here. And then the last point, I don't have purple, so I'm going to have to use black right here. That would be 0, 1. Okay, 0, 1 is right here. So this part right here, I'm going to draw the box so we can see which one it would be right there, would be our inverse. So if you've got points, inverses are very simple to do by just switching those x and y's. Okay, so there is no homework tonight, just